Welcome in our today's mathematics lesson, of which we are still looking at the number and algebra. And today, particularly, we are going to solve equations systematically. In our previous lessons, we have seen equations where we were able to look at equivalent equations. We were able to expand and factorize equations. But today, I want us to start solving equations systematically. Now, I want us to look at a situation here. When you look at a player who plays soccer, the player will always put on a shin guard or a shin pad. After the shin pad, he will put on socks and finally finishes with boots. When the game is over, to remove them, he will again start with this. The last one will be the first one to come out. That is the boot will come out first, then the socks, and then the shin pad. Now, this order of putting on and reversing, same can also be applied when you are talking about the solutions of equations. Now, we find that we can reverse the order as we look for solutions. Take, for example, we have x is equals to 3. Now, this simply means x is equivalent to 3. Whatever activity that is going to happen on the left-hand side should happen on the right-hand side. Now, let us look at this. If you take this, when you multiply this x by 2, then also this side we shall multiply 3 by 2. That one will give us here 2x is equals to 6. So 2x equals to 6. Now, we also can add, supposing we added another 4 here, and we add a 4 here, then you'll find that we shall now get our expression being 2x plus 4 on the left-hand side, and on the right-hand side, we shall have 6 plus 4, which is 10. Now, this equation here has got one pronumeral, or one unknown letter, which is x. If we want to solve for x, we reverse the order, and we shall find that x is equals to 3, which implies that x is equals to 3 is the solution for the expression, or for the equation 2x plus 4 is equals to 10. So this, when I talk about reversal order, we can simply reverse 2x plus 4 is equals to 10 as we go back by first subtracting this. We were adding, this time we shall subtract 4 both sides. We come to 2x plus 6. Then we divide, because we had multiplied, now we divide by 2, and you find that this one becomes x, and the other side becomes 3. Therefore, x is equals to 3 is the solution of the equation 2x plus 4 is equals to 10. 2x plus 4 is equals to 10. This is how we work out while we are solving equations. Now, let us look at a situation here where we have got 3 students who attempted to solve a problem, and both of them used their respective methods, but 2 of them were wrong. One gave us the right approach. The question is 4x plus 8 is equals to 40. That is what we have. Now, we have 3 students. One is called Georgia. In his approach, he did the following. So the first thing he decides to do is to divide by 4. And then he went ahead and wrote, if you divide this one by 4, you'll go and get, this one will be x plus 2 is equals to 10, because this side again divided by 4. That's what he got. And then after this, he went ahead, when he had gotten that, he went ahead again and started to actually work out for 2, whereby he decided to subtract 2 this side and 2 the other side. And when he did that, we have, that is, this one is becoming now, we subtract 2 this side, subtract 2 this side, then we shall remain here with x is equals to 8. Just to put you through, the question that we have here is 4x plus 8 is equals to 40. Georgia decides to divide by 4, so he divided 4x by 4 to get x, then 8 divided by 4 to get 2, and then 40 divided by 4 to get 10. And then finally he subtracts 2 from both sides, then he arrives at x is equals to 8. The second student, in his approach, did the following. And this boy was called Hartik. Now, in his approach, he decides first to subtract 8 from this side. So this side, he subtracted 8, and this side, he added 8. That is how he approached it. Then he arrived at 4x is equals to 48. Then he went ahead and divided by 4, divided by 4. Then you find that what you have is x is equals to 12. That is how he approached it. But we are looking at the correct way of reversing the way we went through the first area. Is which one? Let us look at the third student. This one is Lucas. So he chose to subtract this side and add that side. That's where the difference comes in. The third student called Lucas, in his approach, he decided to pick the following. From the question 4x plus 8 is equal to 40, he decided first to deal with the whole number 8 by subtracting 8 from both sides. So the first thing he did is minus 8 here, minus 8 here. When he does that, it is now 4x plus 8 minus 8. You remain with 4x is equals to, that one we have 40 minus 8. You remain with 32. Having arrived here, then he decides to divide by 4 so that he remains with x on the left-hand side. And this other side, it divides by 4 to get 8. So in his solution, we have x is equals to 8. Now, why are we doing this? You'll always find that every student has attempted, but we want to get the right approach of doing this. Among the 3 students, one has the correct approach of this, and the one who has the correct approach is Lucas. So the question here is, how are we supposed to approach equations while we are solving them? We need to observe and take care of the following into the consideration while solving by equations by systematic way. First, you should have realized that it is sometimes difficult to solve by inspection. So here we require a systematic approach so that we can easily resolve these issues. So to solve an equation in a simpler manner, first we need to find the equation that is equivalent. Now when you talk about the equation that is equivalent, you realize that the moment we had, for example, 3x equals to 3, when we added on the right-hand side, we also add the same on the left-hand side. That one is equivalent. We say x plus 8 is equals to 3 plus 8. This is equivalent. So we are saying here that the first thing we always do is simply to find a simpler equation that is equivalent. And we shall keep repeating this until the solution is found. This is an example of equivalent equations. Then we need to also find that a simpler equation can be found by simply applying the opposite operation in reverse order. When you talk about opposite operation in reverse order, look at this example here. We have 5x plus 2 is equals to 17. 5x plus 2 is equals to 17. Now, when we talk about finding the opposite operation, now we need to find out how did we end up arriving at 5, how did we bring in 2, and so on. So you'll find that when you have, for example, this 5, when you take x multiplied by 5, you'll get 5x. That's very true. That's a fact. And then from here, if this is the case, then you'll find that we can simply break this one this way. Sometimes, if we have combined equation, now, for example, this one we have 5x plus 2, then we need to look at the reverse of adding 2. And to add 2 in this particular case, we shall do what? We shall subtract. So this is where I'm saying we look at the operation of the opposite side. So the very first approach we need to do here, we don't deal with this one first. We deal with the whole number first. But this one I'm illustrating that the 5x can be broken, and it's broken. To break it up, this is how we did it. If we multiply it by x by 5, we get 5x. Which means if we want to go back, we shall take 5x divided by 5, we get x. So, if we are solving this question here, I'll expect you to do the following. First, we shall have to deal with the whole number, so which implies that we shall subtract 2 here and subtract 2 here. And when you subtract 2 here, 5x minus 2, you remain with 5x. And 17 minus 2, you get 15. That is the first step you make. Then the second step now you make, you look at 5x. If you want to break it up, you'll divide by 5, and then also divide this side by 5. When you do that, 5x divided by 5, you get x, and 15 divided by 5, you get 3. So you find that our final solution for the equation 5x plus 2 is equals to 17 will be x is equals to 3. So we have been able to break this and arrive at an answer. We need to observe that this is what we have to do it as we reverse the order. Now, when you get this, a solution can always be checked by substituting the value in its original equation. When I say that, we have the solution here of x is equals to 3. It can always be checked by substituting this in the original question. Now, the original question that we have is 5x plus 2 is equals to 17, and the solution we have is x is equals to 3. Let us substitute and see what we get. So by substituting x is equals to 3 in this equation, we shall be confirming if we have the right answer. We are concerned about the left-hand side only, which has the pronumeral. And that is 5x plus 2. We want to confirm, will it give us 17 if we substitute the value of x as 3? So this one will be 5 into 3, add 2. Now, when you say 5 into 3, the same as 5, multiply by 3 here, then plus 2. This one is 15 plus 2, which is equals to 17. Now, 17 on the left-hand side is equals to the same 17 on the right-hand side. This is to show us that the answer that we have is correct, that the value of x in the equation 5x plus 2 is equals to 17 is x is equals to 3. So this is how we approach this in solving equations. We are going to look at solving a one-step equation and also a two-step equation. Solving a one-step equation. So we are looking at a one-step equation. Solve the following equations systematically. 5x is equals to 30. 17 is equals to y minus 21. And then we have 10 is equals to q over 3. Those are the three equations that we have been asked to solve systematically. And we shall start by simply looking at the first equation, which is straightforward. 5x is equals to 30. So solution here, 5x is equals to 30. We want to see what will happen this left-hand side and what will happen on the right-hand side. From this, you realize that we shall divide by 5, that is the left-hand side, and divide by 5, that is the right-hand side. 5x divided by 5 gives us 1x, which is x. And 30 divided by 5 gives us 6. So for this one, it's just a one-step equation. And find that 5x is equals to 30. When you solve it, you find that the value of x is equals to 6. That one, you find that the opposite of this 5x is the same as 5 times x. The opposite of times or multiplication is division. And that's why we have divided by 5 both sides. The second question, so we agree that here the solution for this equation is x is equals to 6. This is the solution. The second question, where we have 17 is equals to y minus 21. 17 is equals to y minus 21. Now, this, we have a pronumeral and then we have a whole number there. So as we deal with the opposite, as we said earlier on, the opposite of minus 21 will be plus 21, which implies that we shall add 21 this side and add 21 on the left-hand side. Now, when you add that, you'll find that here, on the left-hand side here, we shall have 17 plus 21, which gives us 38. And then this side, it is minus 21 plus 21 is the same as 21 minus 21, which is simply y plus 0. So we shall remain with y. We shall remain with y. Now, if we have y, we don't have any coefficient of y here. As long as the coefficient of y or of prenumeral is 1, then that is the solution. So we can now simply rewrite this. You can by bringing y on the left-hand side and say y is equals to 38. This one is the solution of the equation 17 is equals to y minus 21. This is the solution. For the last one, where we have 10 is equals to q over 3. 10 is equals to q over 3. Now, here, there is a 3 here. This is a division. Q over 3 is the same as q divided by 3. So the first approach here, we shall divide the right-hand side. We shall take the right-hand side, the opposite of division is multiplication. Because this is q divided by 3, then here we shall multiply by 3. And this side we shall also multiply by 3. 10 multiplied by 3, you will get is 30. And on the other side, when you take q over 3, you multiply by 3, you'll find that you should realize that when you multiply by 3 here, 3 and 3 will cancel, we remain with 1 q. So this one, 30 is equals to q. So the solution now becomes, the solution is q is equals to 30. These three questions tells us how to solve the a one-step equation using this method we've gone through, that is in a systematic way or systematically. Now, I want us to also to look at those ways of solving a two-step equation and see how we can work out systematically. Solving a two-step equation. Solve each of the following equations systematically and check the solutions. We are going to solve them systematically and check the solutions. Question 1. Now, the equations that we have, solve the equations systematically and check the solutions. A, 7 plus 4a is equals to 23. B, d over 3 minus 2 is equals to 4. And lastly, we have 12 is equals to 2 in the bracket e plus 1. E plus 1. We have to solve this systematically. So let us start by looking at the first approach, the first question, where we need to see how to approach it. Now, from this, 7 plus 4a is equals to 23. I find that here we need to find the opposite of 7. 7 is a positive integer, so its opposite will be a minus or a negative, which implies that we shall subtract here 7 on the left-hand side and subtract 7 also on the right-hand side. When you do that, 7 minus 7 remains, we shall only remain with the 4a. And this other side, 23 minus 7, will give us 16. So we have 4a is equals to 16. As we saw earlier on, 4a is the same as 4 multiplied by a. So when we are multiplying, the opposite of multiplying by 4 is dividing by 4. So I'll divide this side by 4 and this side by 4. So when you do that, then you find that 4a divided by 4, we have a, and 16 divided by 4 is 4. So you can simply say that the solution for the equation 7 plus 4a is equals to 23 is a is equals to 4. A is equals to 4. However, we were not asked to only stop here, but we were asked to also check the solution. So we are going to take our solution back into the equation and we see how to solve it. Is it working? We confirm by substituting the value of a in the equation. So when I do that, taking 7 plus 4a is equals to 23. This is what we have. But the value of a is 4. We shall substitute 4 where we have an a. This one will be 7. We are concerned with the left-hand side to prove that the left-hand side is equivalent to the right-hand side. So 7 plus 4 in bracket a, where a is 4, should give us 23. Is it true? Let's see. So 4 times 4 is 16. 16 plus 7 gives us 23. So 23 is equals to 23. 23 is equals to 23. If this is the case, then we can agree that the solution for this equation was a is equals to 4. We have solved and we have checked. The second question that we have is d over 3 minus 2 is equals to 4. That's the question I want us to approach. Now, as you see, we first deal with the whole number. So for this particular case, on the left-hand side, we do not start by dividing. This one comes towards the last part because of the quotient issue. But this minus can be worked out first, and then this one follows second. What I'm trying to say is that this is minus 2. The opposite of minus 2 is plus 2, and this side again, we add 2. If you happen to do that, then d over 3 minus 2 plus 2 will give us d over 3. Is equals to 4 plus 2, which gives us 6. 4 over 2 will give us 6. Now, this quotient here, that is d over 3, it is a division. D divided by 3. The opposite of divide by 3 is multiply by 3. So meaning I'm going to multiply here by 3 and multiply here by 3. So d over 3 times 3 will give us d. As you saw earlier on, that when you have a number, if I may illustrate here, d over 3 multiplied by 3, these 3 will cancel, will remain with d. That is why we have d right here. On the other side, 6 multiplied by 3 will give us 18. Now, since the coefficient of d is 1, then we shall say that d is equals to 18. And that is our solution. This solution can be checked by looking at the left-hand side of our equation and substitute the value of d with 18, just to confirm that you have the right answer. To do that, we had d over 3 minus 2. That is the left-hand side, and the right-hand side we have 4. We are not going to tackle right-hand side. All we need is to confirm that this one will give us 4. What is the value of d? From our solution, d is 18. So we shall replace here 18, divide by 3, then minus 2. Let us see. 18 divided by 3 will give us what value? It will give us 6. Take 6 minus 2. So you find that 6 minus 2 will give us a 4. And on the right-hand side, what we have is a 4. We can agree that the solution of our equation is d is equals to 18 is correct, because when we substitute on the left-hand side, it gives us the value of 4, and 4 is the same value that is on the right-hand side. Looking at the last question, the question is 12 is equals to 2 in bracket e plus 1. It is e plus 1. Now, the area where we have the pronumeral is on the right-hand side. This time it's not on the left-hand side. And then we have it in a bracket form, which means there is a coefficient of this outside there, which is a 2. And when we have a bracket, it simply means multiplication. So to approach this question here, we first need to get rid of the brackets. And for us to do that, we shall divide here by 2 and divide here by 2. That is the first approach we shall have to make, so that we now bring our equation in the simplest form. So 12 divided by 2 is 6. And this side now, 2 by 2 will be 1. We shall remain with e plus 1. E plus 1. Now, reaching here, you see the equation we have is just simple. We can work out by looking at the opposite of plus 1. And the opposite of plus 1 is minus 1 here, minus 1 here. When you work out that, you'll find that we are able to say that 6 minus 1 is 5, and e plus 1 minus 1 is e. You are allowed to interchange and put the unknown or the pronumeral on the left-hand side, so that we have e is equals to 5 as our solution. So you can say the value of e here is 5. This can still be checked again from the original question. Let's see. If e is equals to 5, and the question was 12 is equals to 2 into e plus 1. This case, let us take the right-hand side, substitute the value of e with 5, and see if it will give us the value of 12. These 2 into e, and e is 5, and then plus 1. That is what we have. From the order of operation that we learned earlier on, you find that we need to deal with what is inside the bracket first, then we move on. Which means that we shall deal with 5 plus 1, which gives us 6. So this one will be 2 into 5 plus 1, which is 6. So this is the same as 2 times 6, which gives us 12. So the right-hand side has given us 12. Is it the same value that we had on the left-hand side? If it's yes, then the solution for the equation is E is equals to 5. That is the solution of this equation. Now, sometimes you find that we have dealt with equations and you realize that our pronumerals have always been on the same sides. You will find the situation where sometimes you have an equation and this equation has got pronumerals both on the right-hand side and on the left-hand side. This is a situation where we have pronumerals on both sides. Let us look at such approach. Now, here we have equation with pronumerals on both sides, and for this case, we have 5x plus 4 on the left-hand side, and is equals to 3x plus 10. That one is on the right-hand side. You realize that we have a pronumeral of x on both sides. This is a situation that I'm calling equations with pronumerals on both sides. These questions, you should not look at them and panic. No. They can be brought in a simple way and put the pronumerals on the same side, and you end up with the most simple equation to deal with. Now, there are those equations which have pronumerals on the right-hand side and on the left-hand side. That is equations with pronumerals on both sides. Now, such equations are like 5x plus 4 is equals to 3x plus 10. Now, this question should not give us a problem. We should be able to solve it, reduce the equation first to be as simple as what you've been dealing with. That is, make sure that the pronumerals are on the same side. Now, and for us to do this here, we shall look at this 3x. 3x is plus 3x. So we minus 3x on the right and minus 3x on the left. 5x plus 4 minus 3x becomes 2x plus 4. And on the right hand side is 3x minus 3x, which is 0, plus 10 is 10. So we have a constant 10. Here we are with a simpler equation to solve. So we look at the right-hand side. To eliminate a 4, we shall minus 4 because 4 is a positive, and minus a 4 this other side. Then we shall have 2x plus 4 minus 4. We remain with 2x. And then 10 minus 4 is 6. For the 6, 2x equals to 6, we need the value of x. So this is a product of 2 and x. So times 2, x times 2 is 2x. So then we shall divide by 2 so that we remain with x alone. And then the other side, divide by 2, we find that the value of x is equals to 3. When we get the value of x as 3, we are supposed to check our answer and confirm, is it the correct value? If it is not the correct value, then it means that our answer is not correct. That's why it's always good to check your answer in the original equation. To check this is to substitute x is equals to 3 in our equation that we had earlier on. So let us substitute and see. The right-hand side should equate itself to the left-hand side. So 5x and x is 3, we can rewrite it and say 5x and x is 3, 3 inside bracket plus 4. Should be the same as what we shall have on the right side, which is 3 into 3 plus 10. When you look at this, a bracket simply means multiplication. So this is 5 times 3, which is 15. 15 plus 4 gives us 19. This is 3 times 3, which is 9, plus 10 gives us 19. So we can all see that the right-hand side and the left-hand sides are giving us the same answer. Therefore, the solution for our equation is x is equals to 3. You can look at further problems which have the pronumerals on both sides. Now, the question here, solve for x, given that 8x minus 1 is equals to 4x plus 3. The first approach is to make sure that we have the pronumerals on the same side. So we shall have to work on this by simply, this is plus 4x. So we shall minus 4x on the right-hand side. We shall come and minus 4x on the left side. So 8x minus 4x gives us 4x. And then minus 1 is equals to 4x minus 4x is 0. 0 plus 3 gives us 3. We are now ready to look at the question because it is now simpler. And we can solve it the way we have been doing it, systematically. So the next number to look at is the 1. We have minus 1. The opposite of minus 1 is plus 1. So we shall add 1 on the left-hand side and then also add 1 on the right-hand side. And you find that minus 1 plus 1 is 0, so 4x will remain. So we have 4x is equals to 3 plus 1, which is 4. 4x is not yet a solution for our pronumeral x. So we need to go further and break it further by simply dividing, because this is x times 4. So the opposite is divide by 4 here, divide by 4 here. You remain here with x is equals to 1. X is equals to 1. X equals to 1 is our solution for this particular equation. But you should go back and check. Is it the right answer? And to check, we take the answer, the solution that we have, x equals to 1, by substituting it in the original equation. We should find that the left-hand side is equal to the right-hand side. We know that x is equal to 1. We want to substitute and see what we get up here. So this will be 8 into 1 minus 1 is equals to 4 into 1 plus 3. 8 times 1 is 8 minus 1. And this one, 4 times 1 is 4 plus 3. 8 minus 1 gives us 7. And 4 plus 3 gives us 7. You see, 7 is equals to 7. Left-hand side is equals to right-hand side. Therefore, x is equals to 1 is the solution of our equation. So in general, we find that all equations can be solved systematically until we get the solution of the equation. And even if the equation has the pronumerals on either sides, it doesn't matter. The right approach, when it's used, we shall always have the answer given. Now, let me give you an assignment. So this, we are asked, solve the equation systematically. 22 is equals to 2 into bracket b minus 17, close the bracket, and 5j plus 4 is equals to 10 plus 2j. So, to solve this, let us look at the first one. The left-hand side, we have a whole number, we have a constant. We don't bother much about that, but we shall maintain it. 22 is equals to, we open the bracket here, which will give us 2b minus 34. That is 2 times 17 is 34. Then from reaching there, we need to solve. We shall have the opposite of minus 34, which is plus 34, then plus 34, this other side. So you find that 2b minus 34 plus 34 will give us, this and this is a 0, so it will give us 2b. And then 22 plus 34, you find that this one will give us 56. That is 2 plus 4 is 6, and 2 plus 3 is 5. So then, this is a product that is a times 2, b times 2, therefore the opposite is divided by 2, divided by 2. You find that when you do that, 2b divided by 2 is b, and 56 divided by 2, you will find that this one will give us 28. It will give us 28. That is 28 times 2 is 56, so when you divide, this is what you get. So you can interchange and have b is equals to 28. Then, if this is the case, our solution for this equation is that b is equals to 28. b is equals to 28. You can also check this one out and find if it will give us the right issue. Now, we want to check, and for us to check this out, we have 22 on the right side. We don't bother about it. We move ahead and look at the second side where b is 28 minus 17. So when you look at this 28 minus 17, you'll find that is 11 in bracket. And 11 times 2 is 22. So you find that the right-hand side and the left-hand sides both agree. Therefore, the solution for this equation is b is equals to 28. b is equals to 28. Second question, which was asking us to find the value of j or to solve for j, given that we have pronumerals on both sides, we have to approach it similarly the way we approached any other equation that has pronumerals on both sides. So here we have 5j plus 4 is equals to 10 plus 2j. So if you look at this, the very first thing is to work out on the j's. And that, if this is a plus 2j, then we shall minus 2j here, minus this side again 2j. Then you'll find that 5 minus 2j is 3j plus 4 is equals to 10 plus 2j minus 2j. This one will give us a 10. It will give us a 10. So when you move ahead, we have, that was 5 minus 2 gives us 3. And then we have 10 minus 2j, we have, when you minus 10 plus 2j minus 2j, we have a 10. So the next step is now deal with this 4. So 4, the opposite is minus, so we minus 4 this side, minus 4 that side. You'll find that 3j plus 4 minus 4 is 3j, is equals to 10 minus 4, which is 6. Then we shall have to get this side divided by 3, divide by 3. When you divide by 3, why I'm dividing? Because this is a product. J times 3 is 3j. 3j divided by 3 gives us a j, is equals to 6 divided by 3, which is 2. So the solution for our question here is j is equals to 2. We can check our answer and confirm it if j is equals to 2. Is it true for this? So let us see. When we substitute the value of j in the equation, we shall have 5 into 2 plus 4 on the left-hand side is equals to 10 plus 2 into 2. So 2 times 5 is 10 plus 4. The other side we have 10 plus 2 times 2, which is 4. So 14 is equals to 14. So you can all see that the solution for this is that j is equals to 2. We are able to confirm by confirming our answer. So that is it for today on solving equations systematically. In our next class, we are going to look at the equations that is going to involve fractions, that is equations with fractions. Now, sometimes we have a problem that involves a statement, and I want you to tackle this question about a rectangle, where we will be required to write and solve it systematically. Write equation to solve, and solve systematically to find the unknown value in the following diagram. The diagram we have, you can see it's a rectangle, and this rectangle measures 3 by b, but its area is given as 15. So the first thing you need to give me is write the equation. Write the equation of this. The equation of this, we should take it from the formula of finding the area. We know that the area of a rectangle is simply length times breadth. For this particular case, we already have the area as 15, and then we have length as b and then breadth as 3. So this is b times 3, which will give us 3b. So when you look at 3b, then this is an equation which we can solve systematically. So we shall go by the opposite of times 3 is divide by 3 and then divide by 3. You find that this one will give us 3b divided by 3 is b, and 15 divided by 3 is 5. So b is equals to 5. That is the value here. Now, we can simply check 5 times 3 is 15. But basically, in this question, we were first supposed to find how to formulate the equation, and then having formulated the equation, we work out and solve it systematically. Another one, still on the same, we write the equation and we solve systematically. The rectangle we have is measuring x by 10, and the perimeter is given by 28. We know that the perimeter is the distance round a figure, which means this 28 is the same as x plus 10 plus x plus 10. We need to come up with an equation to show this. So the perimeter here, which I'll call P for this particular case, is x plus 10 plus this side is the same as the opposite, which is x, and then plus 10. Then when you add everything there, you should get the perimeter, which is what? 28. So collecting like terms here, x and x are like, this will be 2x plus 10 and 10 gives us 20 is equals to 28. Now this one has now been simplified to a simple one-step equation. So the first thing we approach here will be now to work on the 20. So we shall simply subtract 20 here and subtract 20 here. When you subtract 20, you remain with 2x is equals to 8. 2x is equals to 8. That's what you have here, because 20 minus 20 is 0, and 28 minus 20 is 8. So what we are remaining here is 2x is equals to 8. 2x is a product of x and 2, which implies we shall divide here by 2. That is what the opposite is, and divide this side by 2. This is 2x divided by 2 is x, and 8 divided by 2 will give us a 4. 8 divided by 2 will give us a 4. Then it means that the value of x here, which is the breadth, is simply equals to 4. And you can confirm 4 plus 10 is 14 times 2 gives us 28, which is our perimeter. So that is how we can approach questions and apply equations when we are given areas of various shapes and perimeter. That is it for today. Hope you enjoyed the lesson. Thank you.